First of all, let's prove the Pythagorean theorem. Let's take four identical right triangles with side A, B, and C and put them like this. We have a big square stuffed with four triangles and a square. 1, 2, 3, 4 triangles and a square with an area C squared. Now we rearrange this picture like this. Rearrange it like this. So we have the same big square stuffed with the same four triangles. 1, 2, 3, 4. And two squares with areas B squared, okay, and A squared. So C squared equals B squared plus A squared, because the loose from triangles areas equal in both cases. That's the main feature of Euclidean space, or the space without time. Now let's animate it a bit so it reminds our real world. In order to do that, we need to add the notion of speed and set a limit which corresponds to real observations. The speed of an object is the magnitude of the rate of change of its position with time. Let's leave the need for definition of time for later. At the dawn of previous century, people, due to many observations, noticed that the speed of light is the highest possible speed, and it is the same for all observers regardless of their speed. The fact isn't disproved to these days. It seems that this is just the feature of our reality unless someone proves otherwise. That gives us the following geometry. Let's set a thought experiment. There are two observers, 1 and 2. One of them S stands on the ground. The other M moves on a wagon with mirror sides. One mirror side, the other mirror side, at a constant speed v. M flashes light towards the opposite side of the wagon, and then after it reflects, catch it back. Both observers catch the time of the process. For different observers, the light kind of draw different paths. For M, it looks like this. Like S moves backwards from its initial position to its final position. And light goes forward and back in time 2tm, tm forward and tm back. For us, it looks like this, like M moves forward, and light goes forward and back with time ts. ts forward and ts back. We know that the speed of light is the same for both. But what is the difference? The difference is in time that experiences each of them. And due to Pythagorean theorem, we easily can understand that. In order to make the math as simple as possible, let's set the speed of light c equals 1. Speed of light c equals 1 in our thought experiment. And the time which experience as observer equals 1 as well. So we set for easy measurement the diagonal distance light goes in amount of time equals 1. C times ts equals 1. Okay? This diagonal equals 1. This side of triangle equals v times ts. V times ts. This side of triangle. This side of triangle. Is c times tm. So we have, due to the Pythagorean theorem, the following expression: c squared times tm squared plus v squared times ts squared equals c squared times ts squared. And if we have c equals 1 and ts equals 1 and cts equals 1, we have the following expression: tm squared plus v squared equals 1, which gives us sense of time visualized through distance, and we can show that through the following diagram. Okay, so c equals 1, ts equals 1, ts times c equals 1. Okay, this is v, this is tm, this is tm, this is time, this is distance. Okay, the greater speed between objects, the more difference between time they experience. The greater speed, the more v, the less time tm. Okay, the light in this diagram experience no time at all. If we trace the light in this diagram, we can see that light experience no time at all. And stationary observers, or this stationary observer, experience no move at all. So it doesn't go anywhere. But it experiences 100% of time. So all observers, it seems, experience less time from the perspective of the of stationary observer. Than the stationary observer. So at velocities close to 0, this diagram becomes Euclidean space. So if we have small v, all observers experience almost the same time. But all it shows that every taken observer actually has its own pace of time. And time is actually some kind of fourth dimension of our world. Even worse, in some circumstances, time is indistinguishable from any space dimension, but we never experience such circumstances. In our human life, we just never meet them. That is Einstein's special theory of relativity in a nutshell. That is one of the main definitions of time through link with the space and movements in modern science, as far as I'm aware.